researchers have pinpointed the natural thermostat that cools the air in Earth's upper atmosphere after violent solar storms. This activity includes solar flares and coronal mass ejections, which release electrically charged plasma from the sun. It is known to damage satellites, cause power outages back on Earth, and even disrupt GPS navigation services. CMEs are powerful enough to send billions of tons of solar particles hurtling toward Earth at more than 1 million miles per hour. According to University of Colorado Boulder professor Dolores Snip, the researchers found that when such powerful CMEs speed toward Earth, they create shock waves similar to supersonic aircraft, creating sonic booms. While energy from the shock waves expands and heats up Earth's upper atmosphere, it also causes nitric oxide to form. This chemical rapidly cools and shrinks the atmosphere. What's new is that we have determined the circumstances under which the upper atmosphere goes into this almost overcooling mode following significant heating, said Professor Nip. It's a bit like having a stuck thermostat. It's really a case of nature reining itself in. While CMEs slamming into Earth's atmosphere can cause temperature spikes of up to 750 degrees Fahrenheit, the nitric oxide can cool it by around 930 degrees Fahrenheit, said Professor Nip. The findings came about when Professor Nip was reviewing satellite data from a severe solar storm in 1967. I found a graphic buried deep in a long-forgotten manuscript, she said. It finally suggested to me what was really happening. As CMEs cause the upper atmosphere to expand, satellites in low Earth orbit experience more drag as they are forced to move through extra gaseous particles. Satellite drag is a major concern for aerospace firms as it causes orbit decays for spacecraft, which eventually burn up in the atmosphere. The new study compared two 15-year-long sets of satellite data. One was from the sounding of the atmosphere using broadband emission radiometry (SABR) instrument riding on NASA's TON satellite. The other was collected by the U.S. Department of Defense satellites. We found that the fastest material streaming off the sun was triggering these shock waves, causing the atmosphere to heave up and heat up, said Professor Nip. But it became very clear that these shock waves were at the root of creating the nitric oxide, which caused the atmosphere to shed energy and cool. The research is to be published in the journal Space Weather, and Professor Nip unveiled the findings in a presentation this week at a meeting of the American Geophysical Union San Francisco. In October, solar winds triggered a giant geomagnetic storm, raising fears that they could cripple power supplies. The charged particles were coming from a coronal hole on the sun that was facing Earth. If Earth's magnetic field was hit by charged particles, the effects could also include radar and satellite interference, causing problems phone and internet networks and navigation services. Power grid operators in the U.S. were put on alert following concerning space weather forecasts, but the impact could be felt all over the world.